for tonight's session, like I mentioned just now, is actually to go through with you even more discussion about the lecture 24 of divergence theorem, because at the same time, I also want to do the revision with regards to the triple integral. So we will discuss more about the Cartesian coordinate system, the cylindrical coordinate system, as well as the spherical coordinate system, how to analyze the questions and then set up the integral properly. So without further ado, okay, let's us revise a bit about the divergence theorem. All right, so the divergence theorem is actually another alternative for us to actually compute the surface integral. All right, so during last week lecture, we did go through and study a bit such that finding the surface integral is the same as finding the triple integral of the divergence of f. So here I actually updated the slide a bit by changing divergence into the formula of del n over del x plus del n over del y plus del p over del z. So this is exactly the divergence that we learned in lecture 19 about the core concept of the vector calculus. All right, so under the divergence theorem, if the question asks you to use divergence theorem to compute surface integral, which means we are going to perform the triple integration using appropriate coordinates. So to begin with tonight's session, and we've discussed example 1, and therefore I will use example number 3 to actually go through with you so that you can see how the solid is projected in another way. Okay, example number 3. Use the divergence theorem to calculate the surface integral, okay, double integral f dot normal vector n ds of the vector f equals to x in I direction plus y in j direction plus z in k direction over the surface of the plane y squared plus z squared plus x equals to 4 bounded by yz plane. So again, whenever you look at the yz plane, the missing variable x means that this equation is actually x equals to 0. All right. And also, given the equation of the surface of the plane, we notice that there exists one circle equations. Here, y squared plus z squared. So this is the circle equation, and therefore, in triple integral, we are going to use the cylindrical coordinate system. All right, since here, the circle is formed by y squared plus z squared, which means the cylindrical formula, the integral will be r dx dr d theta. All right, we actually slightly went through this setup in the previous lecture by recognizing the equation of the surface of the solid. All right, since we already know that this is the triple integral using cylindrical coordinate system, so if we want, we can begin actually try to set up as much as we can currently. So the vector f dot normal vector n with respect to surface is the triple integral. And we know that A must be r dr, r dx dr d theta. Now recorded by the divergence theorem, we are going to compute what is the internal formula of the divergence. So again, the divergence is given by f, which is equals to partial differentiate component m with respect to x plus partial component n with respect to y plus partial differentiate component p with respect to z. Now again, like I mentioned, sometimes the vector f is given, sometimes it is not. If f is given, then make sure now you can already identify clearly that this I direction is component m, this j direction is component n, and this k direction is component p. And therefore, differentiate m with respect to x gives you 1 plus differentiate y with respect to y also gives you 1 plus differentiate z with respect to z also gives you 1. So the divergence of the vector given is equals to integer 3. That is 3r dx dr d theta. Now, since we are fixing dx, look carefully, x is actually bounded by x equals to 0, yz plane, and also the surface of y squared plus z squared plus x equals to 4. Now, if we try to simply rearrange this equation, that is y squared plus z squared plus x equals to 4, you should recall under cylindrical coordinate system, whenever you have a circle equation, this circle equation can be represented immediately by r squared. All right, so again, when we learn about circle equation, any pair of squared variable, when you add up, it can be represented immediately by radius squared. So plus x equals to 4. Therefore, the upper interval simply x equals to 4 minus r squared. Now, this is to say that this interval dx, let me change the color a bit. The internal integral dx is actually integrated from yz plane, x equals to 0, until x equals to 4 minus r squared. All right, so what about the radius? Well, the radius can always be found by solving the simultaneous equation of the surfaces given. Now, in each questions in vector field, you will always be given two surfaces. The first is the plane y squared plus z squared plus x equals to 4. The second surface is yz plane, x equals to 0. Therefore, solve these two equations simultaneously. You should be able to obtain the radius of the circle. All right, so this is the first surface that we have. And the second surface, we have x equals to 0. Now simply substitute this x to here. Therefore, we have 0 equals to 4 minus r squared. And therefore, your r squared equals to 4. And therefore, the radius of the circle is given by 2. So this can actually be easily interpreted from 0 to 2. Now again, with respect to theta, as I mentioned many times before in the lecture class, if the question never gives you any additional condition for the circle, then we assume this circle is having a full rotation from 0 to 2 pi. So this is the setup of the triple integral using divergence theorem in cylindrical coordinate system. Now remember, we first integrate with respect to x. So this constant 3, if you prefer, you can actually move it out. So giving you the integration from 0 to 2 pi and the integration from 0 to 2, integrate r with respect to x gives you rx. And this is the upper limit of 4 minus r squared and lower limit 0. So by now, when you are able to construct and set up the correct triple integral, suppose as usual, like I also mentioned many times in the class, the next integration with respect to distinct variable should be straightforward. And therefore, if you substitute this upper limit into it, you should obtain a function in r variable. So substitute, this gives you 4r minus r power 3. Substitute 0 in it, 0. So now you have dr d theta. All right, so the next step is to integrate with respect to r. So this is also straightforward, the radius. So from 0 to 2 pi. And that integrate 4r gives you 4r squared over 2 minus r cubed is integrated into r power 4 over 4, and then substitute upper limit 2 and lower limit 0 with respect to theta. So simplify here, 2r squared. So the upper limit into it, so 2 multiply 2 squared minus r power 4, 2 power 4 over 4. So substitute 0 into it gives you 0. So this is again another constant computation. So 2 multiply 4 gives you 8. Subtract to 2 power 4 over 4, subtract to 4 gives you 4. In the end, you have 12. Integrate 0 to 2 pi with respect to theta. And hence, this is just 12 theta and then upper limit 2 pi to 0. So in other words, you will obtain that under the divergence theorem, the flux surface integral is simply by 24 pi. Now again, you will notice that some of the computational steps I omit and I simplify here. As usual, I assume all of you actually already know what happened here. So simply just a substitute upper and lower limit. Suppose you should be able to get the correct integral computation in the end. So basically, this example 3, I want to pick to begin with you, just to let you know also sometimes the solid, the cylindrical coordinate system can happen in any axis. All right, since this question talking about bounded by YZ plane, which is x equals to 0, which means now this x variable will be fixed. Also because y squared plus z squared forms the circle. So you can imagine under the three-dimensional z, y, x. So you can see like this paraboloid is actually forming in this way. Okay, pushing out towards you in x-axis. So this is indeed a paraboloid in the x-axis direction. Well, regardless, like I said, sketching the graph in 3D, it's not a mandatory steps. As long as you can understand what are the informations trying to deliver to you, basically you can set up this triple integral easily. All right, so again, under the divergence theorem, which is to me is a very good practice to all of you, because by the formula of the divergence theorem itself, you can eventually do a lot of revision, a lot of different topics in one single lecture. You learn again how to compute divergence, which we learned from lecture 19. You learn how to set up the triple integral from lecture 15 until 17, the Cartesian, the cylindrical, the spherical coordinate system. Under what properties we pick which appropriate coordinate to go through. All right, so after this example 3, okay, after warming up ourselves with these example questions, the next that I will go through with you from now on is from the past year questions. All right, because I believe that through past year questions, when you see the format, how the questions are usually set up, then you should be able to be more familiar and may probably help you to prepare yourself for the final exam later better. Okay, all right, let's consider this January 2024. Again, questions about the divergence theorem. Now, consider a vector field F in three-dimensional space defined as follows. All right, so whenever you are given the vector F, you can start to analyze the component. X over 2i, so x over 2 is the component m, x cubed z is the component n, and xy squared is the component p. Now use divergence theorem to calculate the outward flux double integral f dot n across the closed surface S of a solid region R that is bounded by sphere x squared plus y squared plus z squared equals to 9. Now, you don't have to worry too much about the technical terms, the outward flux across the closed surface. This whole statement basically just to tell you there is a solid in which that solid gives you surface integral. All right, basically you just need to identify divergence theorem, first term, because divergence theorem tells you to use triple integral. Second, look at the surface or a solid given. If a sphere is given, then immediately we know that we will use this spherical coordinate system in solving this problem. All right, so since we already identified the sphere, so we can now try to begin setting up the spherical coordinate system to compute the surface integral using divergence theorem. So again, f dot the normal vector n, this is equivalent to the triple integral, and we will be having rho square psi phi d rho d phi d theta. Okay, as usual, whenever you have identified the correct coordinate system, I will encourage you to first set up the integral, the Jacobian part here first, so that you can keep track and not overlook it. Okay, because some students eventually they will still forget about this part. So that's why whenever you record the coordinate system, or to make it even better, whenever you enter the exam hall, the first thing is you write out all the Jacobian term of the triple integral set up first. So here, sphere is rho squared sine phi d rho d phi d theta. Now, after the setup, we can next compute the divergence, because by divergence theorem, we want to know what is the del m over del x plus del m over del y plus del p over del z. So given the vector here, x over 2 is the component m, therefore differentiate component m with respect to x, we obtain 1 over 2 plus differentiate component n, x cubed n, x cubed z, sorry, over dy gives you 0 because there is no variable y there, plus differentiate xy squared with respect to z. Also, there is no z variable 0. Therefore, the divergence is simply constant 1 over 2. All right. Now, for the setup of the spherical coordinate, basically, it's relatively easier. You are given a sphere. Make sure you record the spherical equation. X squared plus y squared plus z squared should be equals to radius squared. Therefore, if you have equals to 9, this means that rho is actually 3. In other words, the inner should be 0 to 3, the interval for rho. Again, in this question, you are only bounded by the sphere. There is no additional condition given to the sphere. Therefore, we assume this sphere is a complete ball shape, in that the vertical angle phi will rotate from 0 to pi fully. Now, just also to remind you, the vertical angle phi will only take the value in between 0 and pi, because the vertical axis z will rotate from 0 until 180 degrees. All right. And finally, theta, which is the horizontal angle. Since this is a full ball shape of sphere, therefore from 0 to 2 pi completely. So you will notice that this setup is just a simple spherical coordinate system. And now you can proceed to do any integration technique that you prefer. So first thing first, if I will just factor out 1 over 2 and then immediately integrate rho square. So rho square is integrated into rho cubed over 3. And this is integrated from upper limit 3 and lower limit 0. And I still have sine phi d phi d theta. Now, because I noticed some of you, when you perform your assignment, you do all the integration independently and separately. If you can handle that, then just carry on. All right. If you can handle integrate every integral independently and simultaneously, then just go ahead. Okay. Eventually, the answer will still be correct. If you cannot, then we just do one by one. So in this case, if you substitute upper limit 3 and lower limit 0, so this will give you a very nice integer computation from 0 to 2 pi, here from 0 to pi. Substitute 3 into it, 3 cubed over 3 gives you 9. So here, sine phi d phi d theta. So this integer 9 you can pull out and then followed by integrate with respect to sine phi. So let me continue in the next slide. So this gives me equals to 9 over 2, open integral from 0 to 2 pi. Recall that, integrate sine phi with respect to phi. Integrate sine should give you negative cos. Be careful. And the upper limit should be pi, the lower limit should be 0. Now, as usual, whenever you have the trigonometric integration, please substitute the value and compute using your calculator carefully. Because like I said, some trigonometric functions, when you substitute pi as 0, it turns out that they have values. So this gives you negative cos of pi minus, in the bracket, negative cos 0. And then with respect to theta. All right, so negative cos pi gives you positive 1 minus negative cos 0. This is just 1 plus 1 gives you 2. So that's why be careful with the computation here. So eventually, you'll notice that 2 and 1 over 2 can be simplified. So this last integration eventually gives you integrate with respect to theta, gives you 9. Theta is substitute from 0 to 2 pi. Eventually, you have 18 pi as the surface integral for the sphere in this question. Now, eventually, if you look at the whole process of computing using divergence theorem, once you can recognize the triple integral setup properly, you will notice that finding the triple integral is just the technique of integration that you have learned before. All right, as usual, any questions when you try to solve involving double or triple integral, you just have to make sure the setup that you use are correct. Okay, look at all the information carefully, and then put them into the proper integral. And following the correct integration technique, then hopefully you should be able to get all these solutions easily. Okay, as usual, if you have any questions that you want to ask, you can project on the chat box from time to time. I will go through and see if there is any. All right. So if so far no questions, okay, by right, I will just keep on choosing even more examples to go through with you. Now, the next example that I want to pick in this discussion is actually the next past year question, July 2022. Now, there is a reason why I try to pick up this question to go through with you is because I noticed some of you still have a little bit confused about the cone. Yes, cone is actually kind of special because of the shape and the behavior of its function. All right, because if you look carefully at the questions, the equation here, if you put this square root to the left-hand side, it becomes z squared equals to 9x squared plus 9y squared. Now, because all the variables are having square, some of you will confuse it with sphere. So this is why it would be good for me to actually properly reintroduce back to you the cone equation, the shape, and how it actually different from sphere. All right, so first thing first, let us go through again the equation of the cone. Now look carefully at this cone equation first. you have z equals to square root of 9x squared plus 9y squared. So if you put the square root to the left-hand side, it gives you z squared equals to 9x squared plus 9y squared. Now, when you have the equation, try to arrange them into the same side first. Susun semula semua variable sehingga semua variable di satu side yang sama. So if I rearrange, I actually has 9x squared plus 9y squared minus z squared equals to 0. Now, what I want to draw your attention is actually this operation, minus z squared. You have x squared plus y squared, but minus z squared. This is actually not a sphere equation. If you flip back to the previous example that we went through just now, you notice that for all the sphere equation, x plus y plus z squared, all the variables are actually in addition operation. If all the square variables are in addition operation, then yes, this is a sphere equation. If after you rearrange, one of the operation is minus, then this is not a sphere and probably and most probably is actually a cone. So this is why a cone is kind of special because it looks like a sphere, but actually it's not. So this is the first thing that I would like to remind you. Second is the shape of the cone. Now, like I mentioned, you don't actually need to sketch out the graph, but I would like you to keep this shape in mind. You need to remember for the graph of cone, the graph of cone actually has two cones flipping upside down to each other. So if you look at the lecture 10 in chapter 2, we learned the cone equation before. For cone equation, it always come in two, datang berpasangan. Okay, yang mana cone atas, okay, pointing up. It's like an ice cream cone upward and the inverted ice cream cone downward. Now you need to know the ice cream cone shape pointing upward is positive. The ice cream cone pointing downward is negative. Now, I want you to be careful with the shape of cone is because usually you will notice that bahagian atas di sini adalah plane surface yang rata. Okay, again, usually if you look at the cone shape, bahagian yang rata sebenarnya terletak di atas. Now, why is this important? Because if you look at the question, S is the solid bounded by the cone, z equals to square root 9x squared plus 9y squared, and the plane z equals to 6. In other words, z equals to 6 should be at the upper interval of your integration. Z di bawah adalah function of the cone. So this is the part also I would like to remind all of you. Cone equation comes in a bit different compared to other shapes. All right, again, you just need to know for cone, bahagian yang rata sentiasa terletak di atas. So this plane z equals to constant is always at the upper limit. So if you can catch what I try to deliver here, then most probably from now on, you should be clear with all the equations and how to set up the triple integral properly. So now let us prepare ourselves to go through this question. Let the vector f be equals to xy in I direction plus y squared plus cos z in j direction plus exponent power xy in k direction, where S is the solid bounded by the cone and the plane z equals to 6. Now the instruction, use divergence theorem to calculate surface integral f dot n. Cone has an equation of circle. You can see it, x squared plus y squared. And therefore, for cone equation, we will use cylindrical coordinate system. Now, the question asks us to use divergence theorem. This is to say that for the double integral of f dot n, this is the instruction, and therefore we will set up the triple integral. So this is the triple integral. Like I mentioned just now, we will be using cylindrical coordinate system with r, d, z, d, r, d theta. Why z? Because z is a plane, circle is x squared plus y squared. Now, after set up the integral for the left and right side, let's compute the inner part of the divergence. Now, as usual, in the function vector f, this is component n. This whole part is the component n, and this exponent is component p. All right, and therefore, the divergence of the vector f is given by differentiate n with respect to x plus differentiate n with respect to y plus differentiate p with respect to z. So for component n, if you differentiate with respect to x, you obtain a variable y. Plus differentiate n with respect to y, so y squared is differentiated into 2y. So cos z, 0. Plus differentiate exponent power xy with respect to z, also 0. So in the end, the divergence here is given by 3y. Ingat y tambah 2y sama dengan 3y. So this is your internal divergence function. All right, so let's try to build the interval. So by right, dz will be slightly challenging because this is the axis that is fixed. Okay, but we notice that there are two equations. The cone z equals to square root 9x squared plus 9y squared, and the plane z equals to 6. So like I mentioned just now, the plane should actually locate at the upper limit because the cone shape is always behave in this way. The surface flat should be at the top part here. So what about the surface of the lower limit? We are given the equation z equals to square root 9x squared plus 9y squared. Now try to do a bit of mathematics here, because you notice that 9x squared and 9y squared, you can factor out 9 in the bracket x squared plus y squared. And we learn under circle equation, x squared plus y squared is actually r squared. And therefore, square root of 9r squared is actually 3r. 8 punca kuasa 9, 3 punca kuasa r squared is r. Therefore, the lower limit z equals to 3r. So next, what about the radius? Now, in order for us to find the radius, which is also I've mentioned a few times in the class, to find the radius of the circle, we will also find the intersection between the two surfaces given. You are given z equals to square root of this function, and the plane z equals to 6. Therefore, solve these two equations simultaneously. Now, basically, from here, you can already find the solution easily. Why? Because I just expressed z equals to 3r. Okay, when I try to transform xy into polar, I obtain z equals to 3r and z equals to 6. Solve them simultaneously, 6 equals to 3r, then your radius is immediately 2. And therefore, simply from 0 to 2. Theta for a cone shape is a full circle rotation, therefore from 0 to 2 pi. Now, we are not finished yet because after setting up the integral, after computing the divergence, we notice that there is still a variable y in the internal function. Therefore, we have to further polar transform it. So under xy variable in circle, y is polar transformed into r sine theta. Okay, please remember also this part, like I said, polar transformation xyz variable in final exam usually will not be given. So you need to understand exactly under two variable, two dimension, what is x, what is y, under three-dimensional sphere, what are x, y, z in polar form. So keep track of that. So here we need to polar transform further for 3y by changing y into r sine theta. So eventually, my equation of the setup 3r until 6, 3yr, y changed to this gives me 3r squared sine theta dz dr d theta. So now, if you want, you can proceed to find the integration. The constant 3, well, I can pull it out first and followed by integrate with respect to z. So whenever I try to integrate with respect to z, r squared sine theta, I have not touched it yet. Therefore, integrate z returns me a z variable from 6 to r squared. Now be careful, upper and lower limit has certain value and certain function that you need to substitute. So this gives you 3, integrate from 0 to 2 pi, integrate from 0 to 2, substitute into it, I have 6 minus r squared, and then r squared sine theta dr d theta. Yes, Fawaz.
Sir kan
Yeah.
integral Z tu kan? Bukan Z sama dengan 3R saya tulis R kuasa 2.
Z3R. Tak, seperti sini kan Y kan dah tukar kepada R sin theta. So sekarang ada 2R di sini. 1R, 2R. 3R square.
Bukan. Integrate 3R ke 6 tu. Saya masukkan 6 ke masukkan Z. R kuasa 2 masukkan Z.
Oh, okay, faham. Okay, my bad. Alright. So it should be 3R, right? Alright. So this is actually 3R, right? Thank you. So you are betul. Alright, so check again, 6 minus 3R. Alright, thank you for the mistake correction. So the next thing is, because our next integration is with respect to R, therefore I would consider expanding this R inside. Alright, so continue in the next slide. Okay, I rewrite again all the expansion. This gives me 3, integrate from 0 to 2 pi. Integrate from 0 to 2, and then I have 6r squared minus 3r power 3 dr d theta. So upon the integration with respect to r, therefore 3 integrate from 0 to 2 pi, 6r squared is integrated into 6r power 3 over 3. Minus 3r cubed is integrated into 3r power 4 over 4. And substitute upper limit 2, lower limit 0 with respect to theta. Okay, so 6 and 3 here can be simplified into 2. And therefore, upon the upper lower limit substitution, okay, let me do this one by one this time because the function is a bit complex. 2 multiplied 2 power 3 minus 3 multiplied 2 power 4 over 4. Substitute lower limit 0, everything becomes 0. Therefore, I can ignore the computation. Okay, step.
Sir,
Yes.
sin theta setertinggal.
Still tinggal lagi. Tinggal. Aduh. Okay, thank you. Tertinggal lagi sin theta. Aduh. So dr d theta. Alright, luckily the rest it's not affected that much. And then just bind the big bracket to it, and then sin theta d theta. All right, so continue. 2 multiplied 8, so this is 16 here, minus 2 power 4, 16 over 4 gives you 4, multiply 3, so this is 12 here. Okay, try to check. So this whole part, 16 minus 12 gives me 4. Therefore, pulling it out, I have 12. Integrate 0 to 2 pi, sine theta d theta. So finally, integrate sine with respect to theta gives us negative cos theta. So this negative cos theta is integrated using substitution upper limit 2 pi and lower limit 0. Okay, for trigonometry, let me substitute one by one in case if there are certain computations involved. So negative cos 2 pi minus negative cos 0. So negative cos 2 pi is negative 1 minus negative cos 0 also 1. Therefore, in the end, 12 multiply 0, and therefore the surface integral for this problem to be 0. So let's check. All right. Well, indeed, the answer is 0. So for all the hard work that you did, in the end, you just want to obtain the value 0. Okay, just don't be surprised. You may obtain any kind of values in the end, because the integration also depends on the divergence of the vector. All right. Okay, so again, this past year question, basically the main purpose is to drag your attention again to the cone function and the shape of the cone, so that you don't get confused with the upper and lower limit in your integral. Okay, remember under the cone shape for positive, the flat surface is actually the circle on top here. Right? So that's why if you have a plane, that plane should be at the upper limit. Cone function should be at the lower limit. Okay, just be careful. All right. So this is the third questions in the discussion. So again, we have talked about the spherical coordinate system just now in the past year, and also 2 questions about the cylindrical coordinate system. Now, the next is I want to introduce or to recap with you about the so-called Cartesian coordinate system, because to be honest, Cartesian coordinate system is kind of rare actually in triple coordinate, because most of the shape that we deal are either always a sphere, cylinder, paraboloid, or cone. Okay, so that's why we don't really see that many questions in the exercise with respect to Cartesian. But so far we have one in the tutorial. Therefore, I will move to this tutorial questions number 1. Yes, this is about the Cartesian coordinate system in the triple integral. Now, the question will always be asked in the similar manner. Use the divergence theorem to find the outward flux for the vector f in x plus y I direction plus y squared j direction plus 2z in k direction, where S is the closed surface bounded by the planes z equals to 2x and z equals to 0 with the parabolic surface x equals to 1 minus y squared as shown in figure 2. Now, this figure 2 is actually very helpful. There are a lot of information you can actually obtain from here that helps you to build up the triple integral. Now, since you can clearly see this is not a circle equation, nothing is involving circle or sphere. Therefore, we know that this must be the Cartesian. Now, the first thing when you are able to detect this is the Cartesian, therefore, we want to use the divergence theorem to compute the flux. So by the setup, so the double integral of f dot normal vector n will be equals to triple integral of the divergence. Now, this setup x, y, z can be in different order as you prefer. Now, if you want, you can actually use the diagram given to help you to decide. Now, if you look carefully and study this diagram carefully, you will notice that for the y-axis, again, I mean y-axis, you will notice that for the y-axis here, you have a pair of numbers, +1 and -1. If you really understand how triple integral in Cartesian coordinate works, the outermost integral yang paling luar selalu constant number. So if you want, you can actually put this pair of -1 and 1 immediately at the outermost integral, making dy is the last. All right, y is in between interval 1 and -1. All right, so next is the z function. If you look carefully also from the questions, surface is bounded by the plane z equals to 2x and z equals to 0. Whenever you have a pair of equation given in the question, if you want, that equations can be set as the innermost integral. That is z from 0 until z equals to 2x, making you dz the innermost. And finally, dx, the remaining variable, will be in between. So how to deal with dx? Okay, remember, dx is the movement of the graph from left to right. Now, I'm not sure, do I actually mention about how to observe triple integral the movement of the graph? Now, usually the movement of the graph, we do not look at the innermost. Now, after the assignment, saya harap, I hope all of you understand the innermost integral dz means you are having z projection. All right, the innermost of the triple integral is actually the z projection meaning. So if you understand this is z projection, then dx dy, the next integral, the meaning is the same like what we learned in double. Dx dy meaning the graph is moving from left to right in the y interval. All right, so look carefully, x-axis is at this part. So in other words, the graph is actually moving from x equals to 0 towards the upper side here until you touches x equals to 1 minus y squared. All right, so this is actually kind of straightforward. So the movement of the graph is from x equals to 0 from this axis. You're moving towards the x-axis side until you touches x equals to 1 minus y squared. So basically, if you can handle the graph given or the shape, the figure given, basically setting up the triple integral involving Cartesian should not be too challenging. Okay, what is left inside in the middle will be the divergence. All right, so this time we compute the divergence lastly, because for Cartesian coordinate system, some of you, I believe, still confused in playing around with the XYZ coordinate. Now, again, I want to disclaim for one more time, I use dz, dx, dy here because I can analyze this information straight away from the problem. If you want to change the order, yes, you can still do so. You can make it dx, dz, dy, dy, dz, dx in any order. Make sure if you change the order of the integral here, upper lower limit, you get the correct equation and interval. All right. So again, you can change the order of the Cartesian depending on your choice. Just make sure if you change the order, all the equation fits and correctly mapped to the upper lower limit. All right, so finally is the divergence of the function f. So this is given by the differential component n with respect to x plus differentiate component n with respect to y plus differentiate component p with respect to z. So here, x plus y, this is component n in I direction. So differentiate x plus y with respect to x, you actually get 1. Plus differentiate n component y squared with respect to y, you get 2y. Plus differentiate component p, 2z here, with respect to z, you get 2. Therefore, the divergence is given by 3 plus 2y. So fit in this position lastly, 3 plus 2y, and you can continue to actually find out the integration in the Cartesian coordinate system. All right, never mind. Let me go through with you the solution of this dz, dx, dy. So after setting this up, so let me rewrite again the whole triple integral in the next blank slide. So this is to say again, the double integral, the flux of f dot the normal vector n with respect to surface is given by the outer integral from -1 to 1. The second middle integral is from x equals to 0 until x equals to 1 minus y squared. And the innermost integral will be z equals to 0 until z equals to 2x. For the function 3 plus 2y with respect to z, with respect to x, and lastly with respect to y. Since the first integration is with respect to z, therefore 3 plus 2y is assumed to be like a constant. So from 0 to 1 minus y. So here I have 3z plus 2yz. And z is substituted with 2x lower limit, so upper limit, and 0 lower limit. So substitute 2x into it. Let's see what we obtain. -1 to 1, 0 to 1 minus y squared. So this gives me 6x plus 4xy. Substitute 0, everything turns 0, so should be fine. Therefore, dx dy. So next, I'm going to integrate with respect to x, and therefore giving me the integration 6x becomes 6x squared over 2 plus 4x becomes 4x squared y over 2 with the upper limit 1 minus y squared and lower limit 0. Well, fortunately, all the numbers here can be simplified, so that when you substitute with the upper and lower limit, you don't have to stress with the fraction there. So now 3 multiply 1 minus y squared plus x squared y. So let me put the y first, multiply 1 minus y squared. So this is the part that you have to be careful. Oops, lupa ada 2y di sini. Okay, be careful. Kuasa 2 lagi. So in the end, this string of equation will become quite long and lengthy. So pay some patience to actually work them out. In the end, 3 in the bracket, 1 minus 2y squared plus y power 4. Okay, plus 2y, same goes to here, 1 minus 2y squared plus y power 4 with respect to y. And expand even further before I decide to integrate it. So 3 minus 6y squared plus 3y power 4 plus 2y minus 4y cubed. Expand again, I have plus 2y power 5. Unfortunately, semua tak sama. Okay, 3, 6y squared, 3y power 4, 2y, 4y cubed, 2y power 5. None of them are actually having common terms. Therefore, you have to integrate each of them one by one. In the end, 3 is integrated into 3y, minus 6y squared is integrated into 6y cubed over 3, plus 3y power 4 is integrated into 3y power 5 over 5, plus 2y integrated to 2y squared over 2, minus 4y cubed is integrated into 4y power 4 over 4, plus 2y power 5 is integrated into 2y power 6 over 6 from upper limit 1 and lower limit -1. So here, there are something that I can simplify. 6 and 3 can be simplified into 2y cubed. 2 and 2 here can be simplified. 4 and 4 here can be simplified. 2 and 6 here becomes 1 over 3. Okay, be a bit patient because now the substitution, both upper lower limit ada nilai. Okay, there are values, so we have to substitute upper limit 1. So 3 multiply 1 gives you 3, minus 2 multiply 1 cube, still 2, plus 3 over 5 multiplied by 1 power 5, 3 over 5, plus 1 squared, minus 1 power 4, plus 1 over 3, 1 power 6. So this is the substitution using upper limit, minus substitution using lower limit. Okay, yang lower limit sila berhati-hati So lower limit adalah negatif 1. Negatif 1 kalau kuasa lain akan dapat negatif lain. So 3 multiply -1, this is -3. -1 power 3 is -1 multiplied by -2, so should be +2 here. -1 power 5 is -1, therefore -3 over 5. -1 squared is +1 here. Negative 1 power 4 is also positive. So minus positive 1 plus negative 1 power 6, also positive. So positive 1/3, it's actually 1/3. So also check for me if there is any error. So first thing first, 1 tolak 1 hapus. Plus 1 minus 1 eliminated. Okay, ada lagi ke? Next, 1/3 minus 1/3. Yes, this part can be eliminated. The rest tidak sebab 3 minus 2 plus 3 over 5. So you have this is equals to 8 over 5 minus negative 3 plus 2, negative 1. Negative 1 minus 3 over 5 is negative 8 over 5. Therefore, this gives you plus in total 16 over 5 as the final triple integral. All right, so basically, if you really look carefully throughout this Cartesian coordinate, yes, kalau kamu nak compare dengan coordinate system yang lain, sememangnya Cartesian selalunya lebih panjang jalan kerja. Sebab X, Y, Z semua remain sebagai variable asal. We don't change into R, dr, d theta. We don't change into polar. Therefore, all the x, y, z has their own function and own interval. Therefore, you have to take care of each interval in each integration. So happen in this question, this last integral is a long string that you cannot simplify any further. That's why you have to integrate one by one. All right, so these are just some of the questions from past year and also from the examples with respect to the divergence. All right, so I would still say that divergence, the concept is actually simple. Okay, I mean concept. As long as you can find out the divergence from the vector given, you plug it into the triple integral that you learned before, and that is the divergence theorem in evaluating surface integral. Now again, under divergence theorem, the question will not ask you to verify, because I believe I did mention in the class, divergence theorem, if you want to verify left-hand side equals to right-hand side, is difficult because not always the function are continuous in three-dimensional space. Okay, therefore, up until today, most of the question asked about divergence is always ask you to evaluate triple integral. So any questions from the floor? Okay, usually after discussing these 4 or 5 different examples, I believe the rest will just be the practices that you can go through on your own to familiar yourself with the triple integral setup and the divergence computation. Okay, as usual, practice is the key. Now, if you're okay, then I believe that's all for tonight's session. Basically, this extra class, I just want to go through as much exercises and examples about divergence theorem with you as possible, because I want at the same time to also go through the revision of triple integral. And now, usually, okay, I personally predict, okay, saya sendiri predict, this semester final exam question, maybe divergence will be out again. Sebab secara logic, divergence theorem is the topic that can simultaneously test you how to compute divergence and also how to compute triple integral. So in one topic, I can test you so many things. That's why I actually predict divergence will be out again in the final exam this time. But I may be wrong. Okay, like I said, I may be wrong. Okay, so regardless, triple integral will be in final exam. Cuma saya tak tahu dia akan keluar dengan divergence atau keluar sebagai chapter 2 yang sendiri. Okay, you need to know in the final exam, chapter 2 and 3 are out in the assessment. Okay, it's just that whether they combine under one question or they split it into different, whether regardless which one, you will still need to do triple integral. That's why lecture 24 is a good lecture notes for you to practice all the exercises sekaligus kamu boleh revise ulang kaji untuk triple integral problem. Okay, don't worry. During our last lecture this week, I will brief you and share with you more information about the format of the final exam and what kind of questions you should focus more to score as many marks as possible. So for that, I will put at the last lecture in this way. So tonight, okay, it will be enough for this 1 hour, about 10 minutes, to go through with you a few more examples. So in the next class, we will focus on the last lecture 25 of Stokes theorem. If you have no any issues so far, then I can stop the recording and then dismiss this session. So if you need, you can actually refer to the recording in the YouTube as usual. Until that, thank you very much for your attendance.